Have you ever heard that something called the ozone layer is thinning? Or that your aerosol hairspray is what's causing it? Or that it leads to more severe sunburns and UV rays? This is referring to the ozone hole. But what exactly does it all mean? Welcome to Ozone 101. The ozone hole's proper name is actually the Antarctic ozone hole because when it forms over Antarctica. But before we get into what that is, let's first talk about what ozone itself is. Ozone is a gas comprised of 3 oxygen atoms. About 90% of the Earth's ozone exists in the stratosphere, the layer of the atmosphere that extends from 8 to about 30 miles above the Earth's surface. In fact, the stratosphere is often referred to as the ozone layer. Ozone acts as a sunscreen around the Earth, filtering out harmful ultraviolet radiation, or UV rays, which are mainly absorbed in the stratosphere. Without an ozone layer, UV radiation would sterilize the Earth. With a damaged but still present ozone layer, there would be more sunburns, more skin cancer cases, increased cases of eye damage, the wilting and loss of trees and plants, and significantly lessened crop yields. Suffice it to say, ozone is pretty important for the planet. So, what causes the ozone hole? There are several major factors that together lead to the destruction of ozone, thus creating the ozone hole. Those factors are 1. Very strong winds around the South Pole, or the polar vortex. 2. The sun's rays. 3. Chlorine and bromine compounds from ozone-depleting substances. And 4. Cold temperatures below -109 degrees Fahrenheit in the stratosphere, which form a specific kind of cloud, polar stratospheric clouds. The polar vortex forms in the southern hemisphere stratosphere during the winter as temperatures drop. And when sunlight returns to Antarctica in late winter and early spring, temperatures are still cold enough to form polar stratospheric clouds, and now there's also sunlight. Chemical reactions take place on the cloud particle surfaces, converting unreactive forms of chlorine and bromine into reactive chemicals. The vortex acts as a sort of container, confining the contents of the Antarctic stratosphere within its bounds, allowing the reactive chlorine and bromine compounds to destroy ozone molecules. That's when depletion can occur on a large scale. With the presence of sunlight, the reactive chlorine and bromine compounds produced during winter begin to deplete ozone molecules by stealing one of their oxygen atoms, leaving just oxygen gas, or O2, in its wake. As long as the polar stratospheric clouds are present, these reactions will occur over and over again, until the ozone is nearly gone. This forms what we call the ozone hole, but that's